product of its factors. Factorization is the process of writing an expression as a product of its factors. This is actually the reverse process of expansion. So for example, when we have 2x times x plus 2, we can expand that. If we expand that, that gives us 2x squared plus 4x. And factorization is the reverse process of that, is going from the right hand side to the left hand side. The first factorization method is with the common factors. So we try to find common factors and we take them out. Let's do some examples. A. So we have to factorize this. The expression is 6x squared plus 4x. So we try to find common factors here. So let me write it easier maybe first. 6x squared. 6x squared I can write down as 2 times 3 times x plus 4x I can write down as 2 times 2 times 3 times x it should be, plus 4x we can write down as 2 times 2 times x. Do we see? I have a common factor here, 2 and 2. I see another common factor which is x and x. So I take out the common factors, so 2 times x, and then what is left in the first term? The 3 and the x is left, so 3x. Here in the second term, the 2 is left, so we do plus the 2. That's the answer. So in the beginning, you can maybe use this step here, but actually you can skip that step and go straight away to the answer, because like we have 6x squared plus 4x, and you should actually see straight away that the common factor here is 2x. If I take 2x out from the first term here, 3x is left, because 3x times 2x is 6x squared. From the second term here, I take again 2x out, and then 2 is left, so it becomes 3x plus 2. Actually, we should see that straight away. If you don't, then you can use this step. And then b minus 4 times a plus 1 plus a plus 2 times a plus 1. The common factor is, in this case, the a plus 1, because we have them in both terms. So if we take the a plus 1 out, in the first term here, minus 4 is left. In the second term here, a plus 2 is left. That gives us a plus 1 times, and then I have a minus 4 plus 2, which gives me minus 2, so a minus 2. And you can see here that it's factorized, because I wrote it down as a product of its factors. The first factor here, the second factor here. Here as well, the product of factors. Okay, let's go to the next factorization method. The difference of two squares factorization. So when we were expanding, we learned that a plus b times a minus b is equal to a squared minus b squared. So now you're going to do the reverse process. So we have to go from a squared minus b squared, which is the difference of two squares, to the left-hand side. So that gives us a squared minus b squared is equal to a minus b or plus b times a minus b. And that's how you write it down as a product of its factors. Okay, let's do some examples. We have to factorize it. 4 minus 9y squared. So we have 4 minus 9y squared. The 4 I can write down, maybe to make it easier, as 2 to the power of 2. And the 9y squared I can write down as 3y to the power of 2. And I can see very clearly that this one is in this form. A squared minus b squared. My a is a 2, and my b is a 3y. So that becomes 2 plus 3y. I use this formula here. So a squared minus b squared is equal to a plus b times a minus b. So the a is a 2 and the b is a 3y times 2 minus 3y. And that's the answer. Fully factorized. Okay, let's do b. Here I have 9a minus 16a to the power of 3. Okay, yeah, I can't use this formula straight away because like I can't put it in that form unless I take something out, unless I take the a out, because I have a common factor here. See, like I have an a here and a to the power of 3, a to the power of 3, yeah. So I take the a out. If I take the a out, and then 9 is left here, and here 16a squared is left. So it becomes a times the 9 is a 3 to the power of 2. And the 16a squared I can write down as 4a to the power of 2. Yeah. And now it's in this form, so I can write it down as a times 3 minus 4a times 3 plus 4a. Now I can see that it's written as a product of its factors. So a times 3 minus 4a times 3 plus 4a. Okay, let's go to the next factorization method. It is the perfect squares factorization method. We know from the expansion laws that a plus b to the power of 2 is equal to a squared plus 2ab plus b squared. Here we have to do the reverse process. So when we find something in this form, so a squared plus 2ab plus b squared, we should be able to transform it to a plus b to the power of 2. The same for a squared minus 2ab plus b squared. That is equal to a minus b to the power of 2. Okay, let's do some examples. First one, 4x squared plus 4x plus 1. I can write that down as 2x to the power of 2 plus 2 times 2 times x plus 1 to the power of 2. And that is in this form here, a squared plus 2ab plus b squared. The a is equal to 2x, the b is equal to 1. And that becomes 2x plus 1 to the power of 2. I use this step to make it easier, but if you see straight away that 4x squared plus if you see that in 4x squared plus 4x plus 1, the a is equal to 2x and the b is equal to 1, you can go straight away to the answer. Okay, b, 8x squared minus 24x plus 80. Okay, so here, what I see here is I have a common factor. So I take that out first. The common factor that I have is a 2. So 2 times, between brackets, 4x squared minus 12x plus 9. That is the common factor. The 2 is the common factor that I take out. That is what I get. In fact, if I take the 2 out here, I get a 4x squared, and here a minus 12x, and here a 9. Then I have 4x squared minus 12x plus 9. So the 4x squared I can write down as 2x to the power of 2. And the 12x I can write down as minus 2 times 2x times 3. 9 I can write down as 3 to the power of 2. Here I see that the a is 2x and that the b is 3. So that becomes 2 times 2x minus 3 to the power of 2.